So I've recently been advised that I must inform everybody that I am in fact a Cisco employee, but that the video content of my videos here do not represent Cisco or the position of Cisco in any way whatsoever. So with that in mind, let me present Cisco Extended Detection and Response for Cisco XDR, PNM Sensor 24.04 upgrade, and the Flow Collector daemon 5.1.3. So Cisco recently upgraded the PNM sensor within the last few days. And this video is going to go through and kind of show you how to go from the older Flow Collector daemon running on 20.04 to the new one running on 24.04. So the stated recommended upgrade path is to basically do a rip and replace. We're going to remove or shut down the old 20.04 sensor and install the new one, the 24.04, from scratch. So we're going to download that ISO same place we got the previous one. We'll install that into our environment, and kind of the best way to do it would be to give it the same IP address as the previous sensor and set up the same ports to receive NetFlow on as you had on the previous sensor. And that should be a pretty easy if you're in like a virtual environment. You can just shut down the old one, bring up the new one, exact same IP address, exact same ports available and stuff. And that's going to be the method that we go through in this video here. Now, some good news, the requirements haven't changed for the PNM sensors. If you go into the dock at the URL shown up on this page right here, you'll see that it says that for a flow collection up to 80,000 flows per second, and believe me, that's actually a lot of flows. You only need two CPUs, 2 gigs of RAM, 32 gigs of hard drive space. That hasn't changed from the 20.04 version. And you can see that the next step up, just like before, 520,000 flows per second. That's a heck of a lot of flows too. But all three of those require the same amount of hard drive space. But you can see on that bottom one there that 4 CPUs and 32 gigs of RAM for a modest increase from 520,000 to 523 flows per second that we're bringing in, which tells you really want to build another sensor. Don't go to that third one, just build another one at the second level there, and you're going to get a lot more bang for your buck. So this is kind of the good news, but there is one little exception that I'm going to go over right now. I was reviewing the Ubuntu documentation for 24.04 server running without the GUI, and it says in here that a recommended minimum is 3 gigs of RAM, as opposed to what I found in the Cisco documentation of 2 gigs for the basic PNM sensor install, 2 CPUs, 2 gigs of RAM. So I'm going to be building all my PNM sensors with the 3 gigs just because that's what recommended by Ubuntu themselves when I'm building a Ubuntu server without running the GUI piece to it. So just like before, we're going to go into our XDR analytics portal. We're going to click on the little question mark in the upper right, go down to on-prem sensor install, and there's our new ONA there at 24.04. We're going to go ahead and download that. It'll take a minute. I downloaded my PNM sensor, and I actually am going to be running mine out of VMware. I'm not going to go into vSphere and show you how to build something in vSphere. To be honest, I've done that in another video, and that really hasn't changed. And to be fair, if you need somebody to run you through that, maybe you should go get some help from your server guys when you're building your sensor out. So I'm just going to be skipping to the part where we actually boot up the PNM sensor, and we kind of run through that interface for the configuration. One point I want to make here, though, is you don't need to run this in a virtual environment. It's an ISO. You can install it on a piece of hardware, and I actually have done that with customers as well, just using a small microcomputer or something like that, loading it up on there. As long as it's got some decent CPUs and memory and stuff, and you can run it on a piece of hardware itself. So, but most people I run into actually do run it in some kind of virtualized environment, however, but that's not a requirement. Like I said, it's an ISO. You can install it on just about anything. When you boot your device, this is going to be the first thing you pop up to. It's going to say install the ONA using a static IP. Yes, you do want to do that with a static IP. You don't want that IP address changing. That really hasn't changed for us. And it goes through all of its boot up stuff. All right, we got to our language selection screen now. We're going to select English and keyboard. Yep, English. Done down at the bottom. All right, this is the new network interface. This looks different than it did previously. We're going to go up here. I'm going to select it. The NIC that I have, I'm going to edit my IP address. I do not want it to be DHCP, so I'm going to go down to manual. And for the subnet, it's going to be 192 for my lab, 192.168.128.0/24. IP address of this guy is going to be 128.168.128.250. And the gateway 192.168.128.1. And for the name servers, I'm going to use the umbrella servers. If I can type the IP address in right, there we go, 208.67.222.222, comma for a separation for the second one, 208.67.220.220, and my lab domain is example.com. And let's click save. All right, applying changes. Next screen, we're going to put in our user ID name. Is going to be PNM admin in my case. My server name, same username here, PNM admin. And I'll give it a lab password too. Now, I'll probably do a video that shows you how to hook this into your Active Directory domain again, like I did with the 20.04. So we'll see if there's anything different, but this will be good for our basic admin name. Let's go ahead and click done. Yes, we want to continue. And this part's going to take a bit of time, so I'll probably speed up the video through this, but it does take a minute to do the install from here. Once the install is done, you're going to tab or arrow down to reboot now and click enter. It's the login screen you're going to get when you first reboot it. Let's log in with our PNM admin, put in our password. And the first thing I always like to do is make sure the host file is updated with our host name. You're going to find that this is going to save you a lot of trouble, especially when you do the ICE integration later on. So we're going to go into Etsy, cat out the host name, and then I'm going to go into the host file itself, cat that out, and see that it says, it's connected for the loopback, but I'm going to put our address in here as well. And trust me when I say that you're going to want to do that too. We're going to do that with Vim. Go down here, and let's put it in 192.168.128.250, and it's going to be lab-pnm-04.example.com. And then I'm going to put it in just as lab-pnm-042. Save that. Oh, WQ, not QW. And let's cat it out. Looks good. So we got that right. Now we're going to go in and configure the PNM sensor to connect to our specific XDR portal so that it knows where to send our telemetry to. So we change directory to /OPT. That's OPT /OBSRVBL-ONA. And we're going to give ourselves an LS here real quick to look at the files in this directory. Looking at this, you're going to see three files at the top that start with config. Those are the ones we're going to be focusing on. There's config, config.auto, and config.local. Don't mess with anything in config or config.auto. Any customization that you're going to do, you're going to want to do in config.local and only in config.local. Okay, so this time we're going to use Nano. I used Vim last time. We'll just use Nano just to show you can use either one. They're both in here. You can see it pops up with this strange name, ONA-C4. Let's remove the hash value, and we're going to change this to our name. Otherwise, in the XDR portal, it'll show that dynamically created name there. So we're going to make it ours. And we're going to add another line, basically, observable service key. And that's the service key we're going to get out of our XDR portal. And I'm going to paste it in here, and then I'm going to block it so you guys can't see mine and, send your telemetry to my specific device here because I don't want you sending any telemetry to my portal. So I'm going to be blocking this out. But you paste it in there with the quotes, and that should be good enough. You can Control X, save. Yes, we do. Config.local. We're good to go. Going to restart the service using the sudo service obsrvbl-ona restart command. And then you can hit the up arrow, back that out, and check on status. And it looks like everything is up, enabled, and good. Now I use the sudo service command, the old sysvinit system. The new way they want you to do it is to use the systemmd command, systemctl. But I've been typing in sudo service for so many years that I just do it naturally now. But this is kind of interesting, is from what I understand, and this is a behind the scenes thing, even if you use sudo service, it actually calls systemmd behind the scenes anyway. So it sounds like you're using it either way, but that's probably going to work for quite a while. To verify that your PNM sensor has been configured correctly, you should go into the XDR Analytics portal, and you're going to go up into that portal, go to Settings Sensors, and it should appear on the page displayed here, just like mine. And you can see ours is there, lab-PNM-04. One thing is you want to give it a few minutes. It doesn't happen instantaneously. You do everything, you restart the service. It kind of takes a minute or two to kind of build it up. So if you go up there immediately afterwards and it's not there or it's partially there, just give it a few minutes and it should get all the information exchanged that it needs to and register itself correctly. From the same page, we're going to go in here and configure. Nope, not lab PNM1, wrong one. Lab PNM-04, settings, configure NetFlow IP fix. And we're going to add a new probe. Probe type is going to be NetFlow version 9 for our example. Port is going to be 9995. Protocol UDP. And standard source, go ahead and click create. And there it is. Looks like the probe is enabled and ready to receive. Now, I've talked about what port you receive telemetry on in other videos, 9995 for version 9 of NetFlow is what the Cisco documentation says to use. But obviously, 2055 has kind of been the traditional port we received it on. But to be fair, you can receive it on any port. Um, but what is important to keep in mind though is that for every different telemetry type, the little PNM sensor flow collector daemon needs to receive it on a different port. So if it's ENSOL from like a FTD or ASA firewall, you're going to receive that on one port. Regular NetFlow version 9 is going to be on another. NetFlow version 5 on another. IP fix on another port. So you just don't want to try. We can't just set up one. It needs to receive it all on a different port, and that's still true in 24.04. Now we're going to configure an exporter to send NetFlow to the PNM sensor. So remember, an exporter is anything that can send telemetry, router, switch, firewall, something like that. Some endpoints can send telemetry, but it's just basically, an exporter. When I use the term exporter, I mean anything sending telemetry to the flow collector daemon on the PNM sensor. In this particular case, we're going to use a Meraki device. I've done different things for you guys in the past, firewalls, routers, and switches and stuff like Catalyst switches. This time I'm just going to do it in the Meraki portal. From the Meraki portal, we're going to go to Network Wide, General. And we're going to scroll down. We're looking for NetFlow. It's usually somewhere around there. It is. NetFlow. And we're going to enable it. And we're going to put in the flow collector IP address 192.168.128.250, and we're going to send it on 9995. All right, good, looks good. Let's scroll to the bottom, click save, and let's go down and verify it. And oh my gosh, that was so much easier. There it is, enabled. So much easier than the way we had to do it on the command line. From the command line of the PNM sensor, sudo tcp dump -n, using -n because I don't want it to resolve host names, port 9995, enter. Now in a real environment, you probably want to use the source keyword too, but right now I only have one device sending telemetries, and that's that Meraki device. So it looks like we're receiving it just fine. So we're good to go. Verifying telemetry in the XDR analytics portal. We're going to go into the same place, setting sensors, find our lab PNM 04. We're clicking on all sensor details, and there it is. You should see a bar graph starting to receive the telemetry. Now you got to give this about 10 minutes. It takes a minute for it to come in here and then be reflected up here in the XDR analytics portals graph here. So give it about 10 minutes, and you should start seeing something in there. To find the service key, we're back in the XDR portal. We're going to go to Settings, Sensor, same place we looked at that sensor. Scroll to the bottom, and there it is, says Service Key. Click on Show, and you can copy it. I'm not going to show you mine, but you would click on Show and then copy it, and then you could paste it into your PNM sensor. The official communication from Cisco was to remove your old 20.04 sensor and replace it with the 24.04 version, like I just did. And in the real world, when I did this in a lab, it really only took me like 10 or 15 minutes to do it. So it's actually pretty quick, and it's actually significantly faster than running through and upgrading 20.04 to 22.04 and then ultimately to 24.04. That actually takes quite a bit of time to download and do all those upgrades. So this is probably a quicker method anyways.